Hey, it's Alex Williams of the New Stack. Welcome to the New Stack Makers, a podcast where we talk about application development, deployment, and management at scale. GitLab is a single application for the entire software development lifecycle. From project planning and source code management to CI/CD, monitoring, and security, GitLab helps enterprises deliver software to market at new speeds. Hey, we're here at GitLab Commit in Brooklyn, New York. And today, in this recording, we're talking about automating security. And with me is Shamiq Islam, who's head of application, blockchain, and infrastructure for security at Coinbase, and Philippe Lafoucrière, distinguished engineer at GitLab. Thank you both for joining us. Now, you both spoke at a panel this morning. You discussed security automation. And I'm curious about this concept of automating security. We're talking about it more. In particular, you talked about closing the software development lifecycle loop and the benefits there are to taking that approach. Perhaps, Philippe, you could start off and talk about your background. And I know you came to GitLab through Germanium, which I like to understand kind of the corollary to what you're doing here at GitLab. Perhaps you could talk a little bit about the theme for the discussion. We can move on from there.
Absolutely. So, as you said, I'm a distinguished engineer now at GitLab. I came 18 months ago to the company with the acquisition of Gymnasium, and that was the start actually for GitLab for the security products that we provide today. So getting back to this topic of closing the SDLC loop, the idea behind this is for us to shift left. So being able with the security products that we develop and maintain at GitLab now, to include that very early in the process, and to have the security checks and assessments and the risk assessments directly in the SDLC loop.
Okay. So, when we talk about this from a blockchain perspective, one of the things that I understand from this discussion that you had is that when companies are scaling their processes to produce and deliver software, security is often the last matter that gets resolved. And this creates some difficulties in how the timelines actually work. Can you help me understand that a little bit better? And what is the blockchain perspective on that?
Yeah, I'll highlight the perspective first, if you don't mind. At Coinbase, we deal with a fairly intense risk and security problem of the fact that when a transaction goes out on one of these blockchains, it never comes back. And so in our case, loss and the ability to keep track of money is like a fundamental requirement for our software to be considered appropriate. Right? People come to us because they trust us. And so for us, if we have kind of failures in our security lifecycle, like how we write product, how we ship product, how PMs even design products, and our UX people are working on it, we just start to fundamentally erode at some of these core tenets of what customers are looking for from a high quality exchange. We work with people's money. We have an obligation to that. So for us here, it's, okay, we know we have a strong security requirement. When and how should our dev and edge team think about bringing in those requirements to their process and lifecycle? What we don't want to happen is we spend all of this time and effort building something that's just not fit for purpose. At its core, that's what it means to miss the security requirement here, is no longer fit for purpose. But what we're trying to get at is, hey, the principles aren't very difficult for us. There's two things you have to care about. Don't lose the user money, don't lose the user data. Let's figure out how your system is going to increase or change access to user money, user data, and take care of that much earlier when you're doing your initial design or architecture to make sure that you limit as much kind of negative bad space you have, and we still get the desired outcomes.
The desired outcome. And so what's the disconnect then between engineering, with engineering now, in that regard?
I can answer to that. The problem with security is that it's often completely misunderstood, and we leave the security process at the very end of the SDLC, so at the very end of the software production process. And that leads to have different timelines. So, like, for example, we have the developers that are still on this SDLC loop. So they have their own rhythm, and suddenly we have the security team that is entering the dance, and they have some results that they want to share with the developers team because they are not able to fix that by themselves. So they need to involve somehow the development team. And these different timelines, they are creating friction between the two teams. And in the end, the security team has their own loop, and the developers have their own loop, and we might have a different loop for marketing or for legal, and in the end, we have a lot of loops. So it's not a loop anymore. It's a spaghetti plate where you need to synchronize everyone all the time, and this kind of synchronization is creating, again, a lot of friction between the two. So that's why we want to have a single loop where we can involve all the stakeholders at the same time. And when we merge something in a project, we want to have all the decisions being taken at that point, so that we create a checkpoint in time where we can never go back. It's a gate, and we don't have any team afterwards that is saying, oh, we didn't know, or we want this to be different. No, it's a gate. You never go back, and you always move forward, so that if you want to change something, you create a new loop, we involve all the stakeholders again, and you can move forward from there.
I'll add a point to that. One of the tasks kind of given to an executive running a company is efficient resource utilization. How are we going to put the right pieces in the right places? Generally, security people are hard for us to hire. They're hard for us to train up, and it's just we have a limited number of them and limited amount of time. When you have mostly manual security processes or semi-manual processes, like a security person has some tools to assist them in their job, but primarily it's still a human doing the work. There's just more generic, in quotes, dev work that's going into the production of software than there is like relative security resource to make sure it's secure. And so if we talk about kind of this, why does it come later? Well, it's more efficient that once we actually get products that are likely to make it out the door, then use the additional effort and money. It's almost like you wouldn't paint the house until the house is mostly done, right? And they're kind of considering that paint step. But what we're saying is, no, this isn't paint, this is structure, right? We actually need to bring in the resource early because the bones aren't good. We can talk about paint later.
So you talk about the paint later. So, one of the key tenets of DevOps has been that, it's solving the problem of developers building the applications and throwing it over the wall to the networking team, who then configures it for the infrastructure. Here we're talking about throwing it over to the wall, getting it configured, and then giving it to the security team. And so, DevOps provided that capability to find these common grounds, so companies, organizations could do this continuous delivery, so they could then use these principles, based upon their teams and their workflows and the technologies that they use to create a much more kind of continuous cycle. So how do you build security into this continuous cycle to allow for, a more fluid environment that we've seen emerge with continuous development and DevOps principles?
I can answer to that. You are mentioning DevOps, and that's a great point, because in the last few years, we've moved from a model where we were doing basically waterfall, and where deployments were done like every month or so, or maybe 6 months or so. We switched slowly to what we call agile, and then we started to switch to a rhythm that was more like days or weeks. And we are today at the DevOps period where we deploy we can deploy like every minute. So the only way to move from this waterfall process to this DevOps process is to automate everything. And when you start thinking about it, if you don't include security in that process, if you don't automate security from the beginning, it's never going to fit in this very aggressive rhythm that we have today to ship always faster, always bigger, and always stronger.
Yeah, the thing I'll add to that as well is part of why DevOps has been successful is it's developer empowering. You allow your engineering team to be able to use the tools, get the instrumentation, understand how the software is running, and then make sure that their software actually lands appropriately. Some of the difficulty that we have on the security side is where we can, we have tools available that allow a developer to like essentially security instrument their code. Am I writing code that is secure to begin with? But some of the stuff around just reasoning, right? Is this business logic funky? Is this like, do I have an integration test that tests like this edge case that the security person brought up, but you know, the rest of the organization has not, just isn't quite there in a more mature state. And so part of what we're kind of, the tension that we're pushing is we need to push towards enabling these engineering teams to be able to make their own decisions and make high quality decisions. But we also need to build tooling that lets them draw the inferences, you know, be able to make these high quality decisions. And there's just this tooling gap, right? Is this going to lead? Well, your common static analysis tool is going to generate more false positives. It's like the squeaky PD that's just paging people all the time. It just gets disabled. And so static analysis is very similar. It's squeaky. It has tons of false positives. Well, this is not a high quality alert. We shouldn't have this as part of our DevOps lifecycle. We should not have this as part of our Dev Security Ops lifecycle, right? And so until the tooling gets better, you're kind of stuck almost with, let's talk about high quality design, make sure we don't have as much to worry about, but then we still have to do this manual analysis.
So what are some of the improvements that we're starting to see in the tools that automate security?
So at GitLab, I think we're doing security a bit differently than all the others, especially because all processes are living right into the process. We are right into the pipeline, and we want, for example, the merge request, which is the page where you decide to merge something in your project. We want this merge request page to become a dashboard where all the decisions would be made at that point, again, to create a checkpoint in time so that we never go back from that point. But we also include security in that process. That means in this merge request, for example, and we drink our own champagne here, we have a security widget where we display to the developers only the findings that they will introduce or fix with their change. Not the whole list, but just what matters with that change. So that will reduce the amount of information to deal with to the very minimum. If they don't know how to deal with that, if they have no idea how to remediate a vulnerability, they can involve the security team at that point, but they are not obliged to. So with that, we've seen that at GitLab. It's a great success because our security team is kind of small compared to the number of engineers that we have. It's like a 1 to 10 ratio, and they can't be involved in all the merge requests that we have. That's very obvious. So we involve them only when they are really needed, only when we don't know what to do with the finding, or only when they are needed to dismiss and to create a kind of exception for a finding. And that's kind of disrupting how security is done in many, many places. And we have that process in place so that we can involve very early all the engineers that we have. We can start to educating them with security. And at the same time, we have security team dealing with all the tricky cases, all the things that our tools were not able to find in the first place. So I'm not saying that the security tools that we have are going to solve security. It's never going to be the case because security is always a trade-off. But at least we are going to catch all the low-hanging fruits so that we will give more time to the security team to deal with what really matters. And this is how we are scaling security.
What are some of the low-hanging fruit?
It's like, for example, the dependencies. It's basically the reason why I created Gymnasium a long time ago. We were doing a lot of different projects, and we had a hard time to figure out what would be the project impacted by some new advisory that was coming out. And at the time, it was 2011, there was nothing on the market that would be able to do that. And it was quite easy actually to have a database of advisories and being able to match that with what we have in projects. So we started with Gymnasium with SID to do dependency scanning. And it worked great. That's a low-hanging fruit because it's quite obvious that if you are using a dependency that is known to be vulnerable, it's a true positive. So that's the kind of things that we don't want to see on production. And I can, for example, mention Equifax. They had a huge data leak in 2014, and it was actually due to a dependency that was known to be vulnerable, and it was known to be vulnerable for 7 months in this company. They knew they had this problem, but security was not part of the process, and they couldn't find anyone to fix that in time, and it was already too late when they discovered that the data was out.
So Shamiq, what are some of the approaches that you're finding are improving your own software development lifecycle?
Yeah, so for problems where we couldn't build tools to detect them, like a static code analyzer or a dynamic code analyzer, we just kind of turned to their side and built libraries that just prevented the problem altogether. So to the degree to which it was difficult for our services to authenticate and authorize against each other, we instead invested in tooling and invested in libraries that made it very easy for our dev team to basically automate away. And so what we decided was any place where we could, we would build the library because it would have a higher return and we'd be able to, at a minimum, create a template and drive that template with other teams with regard to what we needed to see fixed. This similarly went forwards with like, hey, here are known good implementations of Ruby or Golang. Use this as your default template when you're writing a new service. It'll come with all the bells and whistles such that you are like at spec, at actually the top end of spec for where we want to be. So rather than putting like the requirement onto the eng team to say, hey, you have to do this, and you have to do it this way, and you have to do it within your timeline, and I know you didn't plan for this because you asked us a little bit late, but now your timeline is at risk. We're like, here's a tool, here's a system that's already done for you, so just use this thing, or you can go do all this work yourself, right? And that made the choice almost trivial. Everyone would pick up the tool that is fit for the job rather than the tool that wasn't. And the people who picked up the tools that weren't had like high quality reasons, and we worked specifically with them to make sure that they still kind of fit the mold.
Developers don't like to make their own tools?
They do, right? And part of what we want to add is like, my team is an eng team and a developer team. So we make some tools as well. We just make sure that other people can use them.
So, we've talked a little bit about this new DevSec approach, right? Where like it's baked in almost into the process. You're talking about, the choice of tools, for example, that you can use. There's scanning, there's better code scanners right now. Mm-hmm. You can better determine, the licensing on an open source technology that you may be using. So when you're thinking about, going forward and the thought process that you follow and thinking through what engineers are looking for, what are those key themes that keep coming back to you?
I'll hit this one first if you don't mind.
Absolutely.
One of the pieces that we've started to pick up is a large growth in serverless, and just kind of this API is composed of a set of functions that are running on somebody else's cloud, and we throw a router in front of it. A lot of traditional security tooling just doesn't align with the concept of your application is intensely distributed, right? Where we understand microservices because they're still an API, a database, some interaction model, but it follows like the same service pattern, just smaller. When you start throwing in lambdas and microservices, it just completely blows away like what is talking to what and where is that actually being annotated. Where it used to be we could go look at the router of an application and understand here's how logic flows and here's how things get called. Now we're looking at like cloud configuration and saying actually how are these things all rigged up together? What can interact with what and how? And so it's completely kind of changing core understandings and instrumentation of how is data flowing through a system.
So the serverless approach is starting to change it, and you're finding it through those functions to like add another kind of level of programmability that you just didn't have before.
Yeah, and like what's nice is a lot of these providers, the cloud providers, give you good instrumentation into what is being invoked by whom, under what privileges and whatnot. Where historically you had to go pick up a debugger, sit down with the machine and say, well, what the heck was going on? What is my stack trace? Now, Amazon, for example, will just give it to you and say, this Lambda called this thing, which then did this, which then did this, and you see the full path. But you have to know how to like find and interact with it.
What's your angle then on new approaches? You know, serverless is an angle. Is that part of your angle that you're looking at? Are there other what are the approaches that you're seeing that your customers are asking for that you're finding might be effective in improving your DevSecOps experience for your customers?
So yes, they are always asking for more, obviously, and serverless is part of the equation. There is nothing really specific about serverless. It's just, as you said, a service that is running on someone else's computer and without any database or connections or microservices behind it. It's quite easy actually for us to secure that kind of things. It's mostly about scanning the code before shipping that, and afterwards being able to monitor the activity on that kind of service. So we have something upcoming in GitLab that we call Defend. It's a new sub-department, and that department will have a lot of categories, and one of these categories is UEBA, user and entity behavior analytics, where basically we would be able to grab all the logs of the application and figure out what is beyond normal, what is not usual, and trigger a notification to the administrators or to developers saying there is something ongoing on your application. Eventually, we will also block if we are absolutely sure that it's not a false positive, but at least we will start there.
That gets complicated though, doesn't it? Because I mean, I was listening to a presentation at the Open Source Summit about how bugs, for instance, in Linux distribution, in the Linux kernel development, often take a long time to be resolved, and those bugs often have turned out to be very serious vulnerabilities. Mm-hmm. So, what are some of the new mechanisms you're looking for in scanning tools to root out some of these anomalies?
Do you want to kick in?
Yeah.
I know what you're going to mention.
Maybe you do, maybe you don't.
Part of what I'm very interested in, especially when it comes to open source dependencies, where the Linux kernel is a core open source dependency,
is what is my actual source sync data flow analysis and taint analysis. Very often, there will be a critical vulnerability somewhere deep down in the depths of this code, but for all intents and purposes, my system will almost never use it, and that code never gets invoked. It's essentially dead code.
If I'm able to then just kind of using some of this behavior analysis, identify,
am I ever traveling down a path that's going to end up in this vulnerable path? If so, let's just kill execution. I essentially just want to sidestep the problem and say, I don't need to patch it, therefore it's fine that it's vulnerable for a long time. And I'm positive that if it ever starts to get executed, I have something else going on that I need to go get resolved out. Build around.
I was sure you were about to mention fuzzying, actually.
Oh, fuzzing is useful, right? The automated testing there?
Yes, I think that in this kind of case, it really helps to figure out, not to figure out, but to find the edge cases. It's like, you're freeing a monkey on your application with a knife and just waiting for something to happen. Believe me, most of the time something happens. Your application is getting really, really knocked on by these kind of processes. So that's the kind of new features and new methodologies that we can bring to the table.
Well, I have a question for you there. So let's say you do start fuzzing, right? And you find a Linux kernel vulnerability, and one that you actually care about, right? You can find plenty that you don't necessarily care about. What do you do next? Because this merge is going to take forever to merge in, and it may take weeks to months. So now you're sitting there, you found the bug, you're waiting for the Linux kernel to patch it, and you know that you care about this bug, right? So fuzzing is useful, but now what?
Absolutely, that's not going to solve everything, and that's a great point that you mentioned that, because the tools are not doing everything. We still need the humans for that. I'm pretty sure that in 20 years, we will still have security teams, like we still have today QA teams. We still do QA, but guess what? We have a lot of unit tests, but we are somehow relying on humans in the end to do the very final steps.
Yeah, we could talk a lot about this. I would love to follow up sometime. But thank you very much for taking the time to talk today. We covered a lot of ground and some of the issues that come with security, and security being the last thing to be taken care of, and how that can change timelines, how that's been remedied by, I believe, the interest in DevOps and thinking how you can bake security in as part of that process, but then also thinking through like what are those low-hanging fruits, what are those real hairy issues out there, and it seems like we've concluded on that one with just the human factor that we all have to understand. So thank you very much both for your time.
Thank you for having us.
GitLab is a single application for the entire software development lifecycle. From project planning and source code management to CI/CD monitoring and security, GitLab helps enterprises deliver software to market at new speeds. Listen to more episodes of the New Stack Makers at thenewstack.io/podcast. Please rate and review us on iTunes, like us on YouTube, and follow us on SoundCloud. Thanks for listening, and see you next time.